Are you seeing these 17 little letters here ranging from 0 to 9 in AF? Well, they were hidden until a few days ago, and when the lucky one found these letters in sequence, he instantly won 6.6 bitcoins, equivalent to 2 million reais. These bitcoins have been hidden since 2015, and the last one was found in 2022. Considering that this year I started making many videos on this subject, so a lot of new people started searching for these bitcoins, especially in Brazil. But we have a community worldwide of cachetais, who are digital hunters. People who, as a hobby, keep searching for these bitcoins or these treasure hunts that are hidden in the digital world. Today, I will show you various ways you can also search for these bitcoins, even if you know nothing about code or programming. I will explain what your chances are of finding a bitcoin and what you should do if you find one of these bitcoins, all right? Because this is a whole world, we have several videos here on the channel explaining everything. In this video, I will summarize everything for you. I think the easiest way is with web lottery, you see? You go to this address on my GitHub, you can access it from your phone, computer, or anything that connects to the internet, and you have a button that you click to play. When you click, this matrix screen will appear. Some older phones might not show it, but don't worry. What it's doing in the background is searching for your Bitcoin key. You see? In this case, it stopped searching and said it didn't find anything. This was my last searched key. Remember I told you about those 17 little numbers? So, it keeps trying to find them for you very quickly using the computer or phone's processor. And if you find those exact little numbers like the ones here, you will have access to the Bitcoins because that's how Bitcoin works. Bitcoin has a private key. Whoever has the private key, right? Which is like the password for Bitcoin, has access to the Bitcoins. These keys here, they were hidden. Whoever finds them has the right to use these 6.6 Bitcoins. In this case, the 6.6 has already been found. So now there are 0. We move on to the next wallet, which is 67, which has 6.7 Bitcoins. That is a little more, 0.1 Bitcoin more than the previous wallet. And there are still all these wallets here where the balance is green to be found, meaning the Bitcoin is still there. No one has found these wallets yet. One thing that many people ask me is how these codes work offline, right? Ideally, you should always run these codes offline, so you don't run the risk of being robbed in case you have a virus, malware, something like that. Well, it's very simple, folks. This site here, which is the private key site, is not the official site of the challenge creator. It's just a site that provides the information. Many people get confused. Many people think that, oh, when the challenge is solved, it will appear here. There was even a guy who said he won the challenge. We know he's lying, but he claimed, I won so much that I revealed the key before it was revealed on the official site. It's nonsense, folks. This is not the official site, but it shows the puzzle information. It's not the official site, because if we go to Wallet 120, we don't have the private key revealed, only the public key. Because whoever found it did not reveal the private key, only the public key of the wallets in increments of 5 are being revealed. The last private key we have revealed is from Wallet 115. So, another way to expose the trickster. Now, pay attention. This site provides in this column the Bitcoin address, which is public information, the address of all the wallets. Both those that have been found and those that have not been found. If we go to Wallet 160, we will have the Bitcoin address, which is the reference of our wallet. If you want to send money to a wallet, you need the address. You send to the address, and this is not sensitive information, unlike the private key. The private key, whoever has it, has access to the Bitcoin. The address, whoever has it, can send to that Bitcoin wallet. That's it. So, it's actually good for you to share your address. People, when they ask for donations on the internet, they provide the address for you to transfer to that address. So, the address is all here, available for us. And the private key, if you notice, is only up to Wallet 66, which was recently discovered. Recently is something that a week ago. Last week it was discovered, so the private key is revealed. 1067 is not yet. And that's exactly what we are looking for. So how does the program work? We want to discover the private key, which is this number here, but we only have an address, which is this number with these letters here. So let's go step by step on how we find the address through the private key. I can copy my private key here. I can go to this calculator, copy it here. You see? And this button here first, it already converts for me, converts a private key to the Bitcoin address. If I click here, it will convert to the address, you see? It starts with 13 and ends with 5SO, which is exactly the address here of Wallet 66. Starts with 13 and ends with 5SO. I arrived at this address through the private key. This, in fact, is a series of calculations that are done, which these calculations cannot be reversed. Just to illustrate for you, I will start again here with my private key. The first calculation is the elliptic curve, which finds the public key. I can execute this calculation by clicking this button here. It also explains it there. Converts a private key to a public key. So now I have the public key. After the public key, we run a SHA-256. And after the SHA-256, we run this algorithm here, the HIP MC60. We put 00, which is the version we are using from the mainnet. Copy all of this, run. Another SHA-256. Run another one and take the first 8 letters from here. You can delete the rest. Paste that last result we copied and run a base 58 encode. And we will arrive at the same place, see? Range, which ends with 5. And so all these calculations are the same as clicking this button here. That is converting from a private key to a public key. The computer performs this calculation very quickly. It can do it millions of times per second, this entire calculation. So what does the computer do? The computer takes any number, converts it, and compares to see if it matches this one. If not, it takes another number, converts it, and compares. Now, and it keeps doing this millions and millions of times per second. Since here we are talking about a combination of 5 quintillion possible numbers, that's why it's so difficult for someone to find it, right? Because you have to be lucky enough to be searching in the exact spot. Obviously, the more powerful your computer and the more efficient your code, the better your chances of winning. That code we saw, for example, for the lottery is not inefficient at all. It runs thousands of keys per second, and that's nothing. If you run more keys per second, a button won't be enough. It's better to run a code. And then we have several codes I will try to explain here. Why sometimes it's better to use one, why sometimes it's better to use another, and try to help you find which is the best code for you. I will start with the BTC Finder, which is on our GitHub. It's a code that was made in JavaScript. JavaScript is a very famous language. It is used on practically the entire internet. It is also used in that little web lottery program we saw before because it can run in any browser. And it is very easy to modify. We have several contributors here who made several pull requests for this code. This code has plenty of videos explaining from scratch how to install, how to run. And if you have any questions, you can always ask ChatGPT. You start like this: ChatGPT, what is the state of JavaScript? ChatGPT, I'm having this error here, help me. It will help you with everything. If you can't manage with ChatGPT or the videos, you still have our Discord group or our Facebook group to ask for help. People ask for help there with the most basic questions, but the folks there are really great and help everyone, so no one is left without help. Everyone manages to run it well, and I'm sure if you ask for help there, someone will assist you. Once you manage to run it, you will see this screen here, see? First thing, it will ask me to choose a wallet. I always chose 66 because I was used to it, but this time I will choose 67 because 66 has already been found, and it has a bunch of cool stuff in this program. But what I like the most is this here. Look, choose the percentage, see? It will tell you to choose a number between 0 and 1. And here, my friend, my lucky hunter, if you're lucky, you'll put the exact number here. See? I wrote anything. And it will start exactly from where your key is. Here in this case, he converted this percentage here, which means 36%, 47, blah, 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 blah. It converted into this key here. Now it's searching from this key here. The speed leaves something to be desired, you see? 16,000 keys per second, but this was the first program we wrote. JavaScript is not a language known for being very efficient, but it was a great learning experience filled with very cool features. This program definitely has a place in our hearts. It's searching there. I'm going to pause, right? Although I will save this number here for later. I always like to check, right? What if I was searching and happened to stop and someone else went and found it? So I'm going to stop here with Ctrl-C and I will stop the program. It will ask if I want to terminate and I will say yes. So folks, now I'm going to show you an example. I'm going to enter 66 again, choose the percentage mode again, and now I'm going to paste exactly the percentage where it is, which is no secret, right? Because once it has been found, the percentage is released and it is displayed here on the site. See? 2562. So, by entering the correct percentage here, it will find it in a matter of seconds because it is starting to search very close to where the key is located. That's why I like this feature so much. You just have to guess the correct numbers, use all your luck, and it will place you very close to where the key is. Now we are already very close. At any moment, it will find it for me. Something that a calculation that should take millions of years will take a few seconds because I chose the correct percentage. And obviously, I'm doing this retroactively, right? Doing this without knowing where the percentage is much more difficult than this way. So let's go. We're already running here. In a few seconds, 35 seconds soon, it will find it. There. Found it in 42 seconds. This is exactly our key, which we already have on the site. And if we had found this before the winner, we would have been entitled to more than 2 million reais in Bitcoin. But okay, I found the private key, and now what do I do? First, calm down, okay? It's not every day that someone finds it. You don't need to rush. It's better for you to study and pay attention so you don't make mistakes. With the private key, you have access to the Bitcoin. But if you don't, transfer these Bitcoins someday, it might be that someone else will also discover this key and gain access to the Bitcoins before you. So, yes, it is recommended that you transfer it to a secure key as soon as you find it, but do it safely, okay? Because there have been plenty of people who completed the challenge, did the hardest part, which is finding the private key, and in the end they were robbed or lost it anyway. They couldn't get the money, which is the most important thing. So, pay attention. If you find the private key, you will need to transfer these funds to a secure 256-bit wallet. Within this, there is a vast topic with several videos here on the channel. I recommend you watch everything. So when you are the lucky one to find one of these wallets, you know what to do, okay? Now, after you have transferred to a secure 256-bit wallet, it's very easy, my friend. Then you open an account at an exchange and you send from your secure wallet to the exchange. At the exchange, you sell for dollars, reais, or your favorite fiat currency. At the exchange, you have a little withdrawal button to redeem the funds. You redeem your reais, pay your taxes according to the country you live in, and go be happy, my friend. I'm not going to make a video about this because there are already many. I searched here how to sell Bitcoin on the exchange. There are already 347 million videos. Probably explaining it much better than I could. You can choose the exchange, from where, etc. So, go ahead and handle that part on your own. What I do want to talk about is BTC Go, which is a newer code than JavaScript, also with many videos filled with cool features. And to run it, the difference is that instead of JavaScript, you will need Go, which is another programming language, a much more efficient language than JavaScript. That's why you'll see that this code here is much faster. Well, Go is compiled, so first you need to compile it. All of this is explained in the videos in the project's documentation. But after you compile, you will have a small program, btc go.exe executable. And then you run it, you'll see that it is very similar to JavaScript. Right away, it asks how many CPUs you want to use. I have 20, I'll put 10 here so I can continue recording without any issues. Which wallet do you want to find? I want number 67. And it also has several modes very similar to the other one, the random mode, which is a mode people like as it searches randomly, maximizing the treasure hunter's luck. But I'll choose just mode 1 here, just simple, just so we can see it working, and immediately get a read on the speed. Do you remember that the other one was running at 15,000 keys per second? Well, this one is running at 2 million keys per second. 1.9 million. Absurdly faster, and that's with only 10 CPUs. I could have added more CPUs here to run it, so the chance of finding something using this program is higher than the other one, okay? Although they are a bit different in their use, maybe in the ease of modification, this one uses multi-threads, which is very cool, very nice to do in Go, and also very easy. I did it quickly with the help of ChatGPT without knowing anything about Go, and it reaches much higher speeds than JavaScript to me because it was made in Go as well, with contributions from various developers, as you can see here on our GitHub, who wrote several pull requests and added excellent code to our BTC Go repository. And there are many codes that we don't even know that we haven't had the chance to run yet, codes that developers created and shared in the group, but I want to show this one more, which is the Key Hunter. In fact, it is just a translation of Key Hunt, which is a very famous code made by Alberto, a great guy. We translated the entire README here for people who don't have a strong grasp of English to be able to read and understand everything, because it has a lot of modes, a lot of things. And it was written in C++, which is one of the most efficient languages out there. I'll run it here for you, just to show how it works. The difference is that I can't run it on Windows, so I'm running it on Linux. But I already have it here, see, a program of the Key Hunter Yaz to run on wallet 67. Here is a random number I chose to start with. Let's change it here to D, I don't know. It's equivalent to choosing the correct percentage there. I tried to choose the right number, and you see here that it's already running? This here, folks, is running at a speed of approximately 70 million keys per second. Here, see? Million keys per second. If we started with JavaScript at 15,000, or rather we started with Web Lottery at, I don't know, 1,000, 5,000, I'm not sure how much it runs there. Then in JavaScript, 15,000. Then in BTC, go with 2 million. Now, using C++, we are running at Mopu 70 million keys, which greatly increases your chances of finding one of these lost wallets, right? From here, to increase more than that, you would need to use the GPU, okay? Everything we've done so far is using the CPU. What is CPU? CPU is a processor that every computer has. And it performs calculations, serially, calculations that help the computer in many tasks, but the GPU is much more efficient for performing calculations that can be done in parallel. For example, here you don't need the result of one calculation to compute the next. You can calculate both in parallel, and if you don't find it, you continue to the third, the fourth, the fifth. You can do thousands, millions in parallel, because one calculation doesn't depend on the other. So with a GPU, you can achieve even higher speeds. That's the next step we're going to take. I'm researching some programs that run on GPU. I'm trying to write my own with the help of my friend GPT. And an update on this topic will probably be released soon. All these little programs have a mechanism. In case you find the key, if you're asleep or the computer turned off, it usually writes to the file, you see? The cat is a Linux command that views the file. And then you pass the file name as a parameter. In this case of the key hunt, the file name is keyfound.txt. So if I press enter, it will show here, look, all the keys I found, you see? This one here is precisely the key for Wallet 66 that I was playing around with finding. So the moment it found it, it wrote it here for me in this file so I could use it to retrieve my Bitcoins. Super important, what to do if I finally find one of these wallets filled with Bitcoins. If you are an advanced key hunter, first of all, congratulations. You don't need to send me any donation, any money, okay? But get in touch with me because I would really like to make a video about your journey. If you are a beginner key hunter, then you have two considerations to make. If the wallet you found is above 100, wallet 100, 101, 102, 139, you will simply transfer to Electron and give Electron to the exchange, as I have already shown here in some videos. So look here on my channel for the video how to redeem, and you'll be fine. Following the tutorial, you'll be able to redeem it without any problem. If it's a smaller wallet, for example, you were looking for 67 and you found it, then, my friend, stop everything. Marathon the entire channel and also research more on your own to avoid making mistakes, okay? This is a very delicate subject. The guy who found 66 last week was robbed precisely because he didn't pay attention to this. We have plenty of videos here on the channel explaining it. Look especially for Experiment 162 and you'll know everything about what's happening. We also have a video here showing it. So what's the solution? The solution has not yet been tested. With a real wallet, it has already been tested in a test that someone conducted. Possibly, at some point here on the channel, we will conduct a test with a real wallet, simulating exactly how we did with Wallet 162. But for now, if you find Wallet 67, simply watch all the videos, join the group, ask questions. Do not share this key with anyone, but study a lot so you can withdraw this money without any issues. If you liked the video, leave a like to combat the forces of evil, subscribe to the channel, and see you next time.